So first of all, thank you very much for coming, as I mentioned. This is the second event, as I mentioned, of a four-part talk. We are going to be looking at humanity and technology, and basically how do we get to the singularity. Don't worry if you weren't here last week. I will just briefly go through exactly what we did do, what we talked about last week. The four parts, as I mentioned last week, is how did we get to here. So what basically we're looking at is how humanity has managed to evolve to the point where they can do the kind of things that we can do using technology. So we looked at how from the very first moment that our ancient ancestors in primitive times picked up tools and were able to use those tools to perhaps like a club to gather food and hunt with. So this was something which sorry, you're getting a notification there. This is something which is kind of inbuilt into the nature of humanity. So we are, as a species, naturally given towards solving problems and looking at problems in unique ways. So, but we were able to use tools to develop new tools. And in developing new tools, the tools that we developed using the old tools were exponentially more powerful than the tools previous. So in terms of ancient times, we're looking at the ability of the discovery of flint, for example, was a tool, and that they could use that to build axes, and they could use the axes to chop down trees, and they could use the wood to build rafts, and so forth. And so it was the advancement of technology is inbuilt into humanity, and the beginning of that was right back in primitive times. And last time, at the last event, we looked at how that progressed all the way through to today. So there's specifically three phases of that. There was the tool-making phase that I've just mentioned. Then we went through an agricultural phase, and then from there we went into an industrial age, right the way through to today, where we're in an information age. So, but the increase in speed of those changes has also been growing at an exponential rate. So, as I mentioned earlier, it would take millennia, literally thousands of years, for the impacts of changes in medieval times to actually have any kind of an effect on humanity. But once we got to the agricultural time, it was more a case that the speed of advance was measured in the hundreds of years, in the centuries. So, and then from there, we went obviously into industrial age, and the rate of change, again, was, because of an exponential curve, was measured by decade. So that's really what we looked at last time. So essentially, the technological curve that we're on in terms of advancement is an exponential curve which started the very first time that an ape picked up a club, okay? And at that point, our destiny, if you like, in terms of technological advance was set at that point. So let me just get back to where I need to be. Just bear with me. So the idea is that tools that we've created increase our ability. Okay. So just over the last few years, in fact, from the 1980s, we're seeing an acceleration increase to the point whereby it's incredibly obvious. It's incredibly obvious within your lifetime, really, to see incredible amounts of change. So from the 1980s, where the personal computer was the advent of the personal computer, right the way through, we had the internet, which is obviously a major event in the advent of technology and humanity. The advent of social media and the spreading of information, this is something which has ultimately been the foundation of the technological growth, because right the way back, and the reason why it took thousands of years for technology to change humanity is simply because information was not passed down very easily. So, initially people didn't have the ability to write things down, and although, when we sort of progressed through time, in fact it was, scribes and monks and there was a group of people whose job specifically it was to write things down, but literacy was very, very low. It wasn't a very, people of the world weren't very literate. So, in fact, it wasn't until about the 1400s, with the invention of the printing press, that technology and knowledge was widely spread and easily read, and people started to become more, able to understand, the concepts that were being developed and the technology that was being developed. Collaboration could happen, so knowledge could be not just passed down through generation, but also between people that have different ideas, and those kinds of collaborations, are the foundations of ultimately, advance. In fact, if you look at most technological advance today, it is actually, the discoveries that we're making. Often the technology is actually emerging of two prior technologies that we already know about to create a third technology which is beyond what we currently have in terms of capability. So we're here. So what is the next few bits of technology which are going to accelerate us forward and to what we call the technological singularity, which I'll talk about a little bit more in a second. So there's actually some critical technologies, some emerging technologies which are by no means the least. There's so many technologies being developed right now. Obviously, we're not going to have a chance to talk about them all, but there's some primary ones which we need to talk about, because these are the key factors of what we're going to call the technological singularity. So obviously we've all heard of artificial intelligence. This is ultimately what will bring us to the technological singularity, but there are a number of other technologies which go along with that are essential to that development. And so we have IoT, or the Internet of Things. We have robotics, blockchain technology, or decentralization we'll call it. And quantum computing / quantum cryptography. So today I'm going to be talking about those technologies, and we're going to be talking about why and how that's going to bring us to the technological singularity. So artificial intelligence. So obviously what we need to do is we need to understand that artificial intelligence is already here. And it has been for a great number of years. There's been quite an acceleration in artificial intelligence through something called machine learning. Previously, artificial intelligence was programmed specifically by a group of developers, and so the idea was that they would try and program into the robot or the AI or whatever it is that the AI exists within, if it's a robot, for example, to actually deal with all of the different circumstances that it might come across at that particular time. So but it's impossible, right? I mean, the world, and that's just not how the universe works. So there are always circumstances which are beyond the capacity of the developer to understand or perceive at the point where he was programming the AI. So something called machine learning was developed, and the idea was that rather than try and program in every possible instance of everything that the AI would come across, that they would give the AI the ability to learn from its own mistakes by giving it very specific end results using neural networking to connect sensors and inputs and giving it a desired output and letting it experiment and running through cycles of tests and cycles, learning how to actually do the task that's been given. But AI is actually all around us all the time, right now, and most people are aware of it in some form, whether that be your Google Assistant or Siri or those kinds of assistants. But it's also in things that you're not probably so aware of. So, for example, as I gave the example last week, in fact, of tumble dryer. So, you put your clothes in it. It has some sensors that tell the humidity inside of the tumble dryer. And then the AI can actually, that's embedded in the tumble dryer, can moderate what's happening based upon a desired set of circumstances that's been programmed. So it's in there, it's in your phone, it's in your car, it surrounds us all the time. I mean, it's getting to the point now where we have intelligent everything. So you can buy intelligent light switches that know how to dim the lights in your room, for example. There are a whole host of different things. But these are examples, all of them, of narrow AI. So narrow AI is where we are today. So narrow AI, as I mentioned, is specifically AI designed to do one thing, okay? So it may use machine learning to learn how to do that thing in the best possible way. An example of that is, I don't know if any of you have been aware of, but there's the game of Go, which is a Chinese game that's been around for 3,000 years or so, and is very, very complex. The game, the rules are quite simple, but the board is very complex. In fact, there's a tree of possibilities, so huge that you couldn't use like a standard AI to play this game. In the same way that chess has a tree of possibilities, a chess AI can actually go through all of the possibilities to get to the best possible, that it thinks is the best possible route. Well, with Go, that's not possible, simply from the fact that there are so many possibilities. Well, there was an AI developed called AlphaGo, and it's actually it was designed to absorb all of the human knowledge of the game of Go, and then played the game against a human. Now, it was quite outstanding this earlier in the year because, last year, because it was 10 years. We thought it was going to be 10 years before it was possible for this to happen, but the actual AI beats the Grandmaster that's been learning to play Go for his whole life, beat him 2-3. Okay, so out of 3 games, the AI won. They then took that AI and they altered the algorithms, and they allowed the AI with no input other than the basic rules of the game. And so there's all these different strategies and things that people have learned over time. They allowed it to play itself, and it played itself with no human input whatsoever. And the AlphaGo Zero then beat the programmed AI that had been programmed with human knowledge, it beat that 100 games, and it lost no games whatsoever. So narrow AI might be narrow in the sense that it is actually, it doesn't have the ability to think like a human, but it can still be very powerful in the sense that it takes typically a human 50 repetitions to learn something perfectly. But that can happen in a blinking of an eye for an AI, and in fact it can do millions of repetitions in a very short space of time and become an expert on anything. So that's narrow AI. I spent a little bit more time on that than perhaps I should, but it's quite an important subject. So then we come to artificial general intelligence. So this is where we want to try and get to, okay? So artificial general intelligence is where rather than being able to use machine learning to solve a particular task, this is a way that machines will be able to address problems and think about problems in ways that are more humanistic. So what do I mean by that? So for example, if narrow AI, if you asked it, if it was in a robot, for example, and you asked it to get from A to B, and there was an obstacle in the way, a narrow AI would probably learn how to jump over the obstacle to get to its destination. Whereas an artificial general intelligence may look at the object and realize that the object actually isn't very heavy and just move it out the way rather than having to jump. So there is a level of cognition there which allows the artificial general intelligence to think more widely about problems. Human intelligence is mostly about pattern recognition. As humans, we're very good at recognizing patterns, and in fact abstract ideas from patterns which maybe on the surface don't seem quite so related, and then come up with new ideas based upon that. Well, this is where we're trying to get to with artificial general intelligence. Now, there is a few projects on the go which are attempting to create artificial general intelligence. I actually am a community volunteer for SingularityNET, which is actually an organisation which is trying to generate and build an artificial general intelligence. So it's quite an important subject, but we'll focus more on that at the next event where we actually look at the singularity. And so that's quite a large subject to discuss, and one that I could literally spend hours talking about, but this is not what the whole event is about. So the next event we'll be looking at singularity, the actual singularity itself, technological singularity. So let me define though for you exactly what that actually means, technological singularity, because some people think that a technological singularity is a point by which that the changes that I mentioned earlier, because they're exponentially growing in speed, that it gets so quick that changes happen. As more changes happen than we know it will impact, how it will impact society. So one of the things about that is that we have AI which perhaps could understand itself and identify its own weaknesses and be able to change its own weaknesses, very much like we can. I mean, we can understand our own limitations and try and learn new skills and new things, right? So if we get to a point whereby we have an artificial general intelligence which can do that, we are at what we call the technological singularity. So that brings us on to the next slide, which is artificial superintelligence, or ASI, which ultimately is often called the post-singularity AI. So if AGI has or possesses the sum total intelligence of a human being or a few human beings, ASI would possess the entire processing power of all human brains on the planet. It is impossible for us to understand or to relate to at this point exactly what that means. There are some people who believe that it is going to be sort of beyond our capacity even at that point to understand. My personal view on this is that rather than it be a scenario whereby it is machine intelligence versus human intelligence, I think that we will incorporate, and we already do, technology within ourselves, and so artificial superintelligence will actually end up being within us, and we will all end up being together in that sense. But ultimately, ASI is the concept where artificial intelligence has got to the point where it is beyond the whole intelligence of humanity. There is an interesting thing to say on this though, and that is we often call it artificial general intelligence or artificial intelligence. But there is it's very difficult to define what that actually means. I mean, there's actual intelligence. The fact that it is the source of that intelligence comes from a place by which we've created. Eventually, it'll get to the point where AI will redesign itself. So we will no longer be creating it. So what's artificial about that? And what is the source of that? And where does the self come in that? Where does the self-awareness come in that? And these are quite existential, philosophical questions that we're asking ourselves at this point, which of course have no direct answers right now. And people have many opinions about this. What is the source of consciousness? These are incredibly deep and meaningful questions, and I think that we will have to start to really, question what it is to be a human being, what it is to be alive, what it is to be conscious, what it is to be aware. These are all questions which we're going to have to ask ourselves as a result of artificial general intelligence and certainly artificial superintelligence. So, sort of moving on from there, the next technology, which is absolutely primary to, the advent of getting to the technological singularity,
artificial superintelligence,
is actually
I like that term.
The Internet of Things. So, an example of this, in 1992, there was 1 million devices connected to the internet. Okay, now the internet has been around for a long time. Okay, not in the sense of the World Wide Web, which was invented by Sir Tim Berners-Lee, but and that came from CERN, by the way. But no, because it's actually been around for a long time. Was invented in the 1950s as a way of being able to get around communication loss. If you've got a line of communication and that is disrupted by a middle chain being taken out, that's no good, certainly in a war. So it was the Americans actually that came up with the idea for a network whereby information can be routed through multiple different ways, and that was the DARPANET and the idea behind the internet. But the internet in 1992 had 1 million devices connected to it. Okay, now to give you an idea of the exponential growth, by 2003, so that's 11 years time from there was 500 million, so 500 million devices were connected to the internet. Now, not until 2009 did we become aware of the concept of an Internet of Things. The Internet of Things, by the way, ultimately is a way of saying that the things that are connected to the internet, which are providing information and pulling information in and is a two-way thing. And it is actually the growth of the Internet of Things is a direct correlation, and I'll show you in a minute of the graph, direct correlation to the exponential growth of technology. So in 2009 we became aware of the concept of Internet of Things, but by 2012 there was 8.7 billion devices connected to the Internet. So from 2003 to 2012, so 9 years, we went from 500 million to 8.7 billion devices. Now, I'll actually, if I can bear with me, just need to get to the slide. So this is the curve, and this is what we're talking about. So ultimately, if I get back to here, ultimately by 2012, 8.7 billion devices were connected. By 2014, 14 billion devices. 2016, nearly 23 billion devices were connected to the internet, and brings us to today, where we have 34.8 billion devices connected to the internet. So if that trend continues, which it certainly will, we will be at 50 billion connected devices worldwide, 50 billion by 2020. So that's quite a lot of devices, and that's certainly a lot of information. So let's have a look at that in terms of population and where we're at in terms of population and device. So in terms of the connected devices of the internet per person, in 2003 we had a global population of 6.3 billion people, okay, and there were 500 million devices. So that was translates to 0.8 devices per person. Now, bearing in mind that obviously in the third world there were no people, and there still are, unfortunately, in the world with connecting to the internet. So these figures aren't, although they're averages, they're not. You don't think of them as being as it says in terms of per person. But in 2010. So we went from 6.3 billion people to 6.8 billion people. So obviously 5 billion people were born between that time, or obviously there were deaths as well, but we grew by 500 billion, 0.5 billion. And so from there we had a total of 12.5 billion devices connected to the internet, which was 3.47 devices per person. So if this trend continues, by 2020 we'll be at an estimated 7.6 billion people on the planet, but there will be 50 billion devices. Now that's on average 6.58 devices per person. So what does that actually mean? I mean, why are we talking about this, and why is that so significant? Well, it's significant because of this. Big data, okay? It's a term which I think probably most of you have heard. Now, what's driving IOTA, and what's driving IoT, what's driving the Internet of Things is that the cost to performance is exponentially decreasing. So, or rather, the performance per cost is increasing. In other words, for every time that we are accelerating in terms of the amount of calculations that we can get in per second, and the miniaturization of technology and Moore's law, the cost of that technology is also coming down. So an example is in 1990 there was a supercomputer which cost millions of dollars. It's a Cray 3, cost millions of dollars, and occupied a whole room. Took a whole bunch of power. And it had the same processing power that you have in your mobile phone, which costs a few £100, and you could charge it in an hour or so and lasts all day. It is an exponentially growing power to cost. Okay, so what this means is that ultimately it's an exponential growth. So people think in a very linear fashion. It's natural, it's human to think in that way. So if we're thinking 30 years ago, people often think, well, if a big supercomputer in a room, 30 years later we've got a mobile phone with the same power, that in 30 years' time then maybe it'll be in the size of a postage stamp, right? But actually, because it's an exponentially growing curve, it isn't even half that length of time. It's a quarter of the length of that time. So because so within 7 years, we will go from, the power in your phone will go from being the size of the phone and costing a few £100 to being the size of a grain of rice and costing just a few tens of pounds. And then 3.5 years later, a year and a half later, it will actually be, will be down to like dust size devices, and the cost will be just a few pennies. And what we're talking about here is being able to we'll have an explosion of Internet things to the point where we can put intelligence in everything. You could put intelligent dust into paint and paint it on a wall and have that sense of everything around it. And so because it's so cheap to do it, it'll happen everywhere, and the capabilities that we will have because of it will be accessible by everybody. But there are some problems because big data, I mean, we're talking about a massive amount of information. In fact, let me just, I want to get back to where I was again, so bear with me. In fact, the problem is that roughly information has doubled every 40 months since about 1980. Okay, so let me just see if I've got the next slide is telling you anything about this. So no, that's robotics. So okay, so we're missing a slide. That's okay. I'll tell you anyway. So information has roughly doubled every 40 months since the 1980s. So by 2012, we were generating daily 2.5 billion gigabytes of data. Okay, that's quite a lot of data. If you imagine that, you know, there's at that particular time you could buy a hard drive, terabyte hard drive, but 2.5 billion was the global data generated during that time on a daily basis. So actually, if you zoom forward to today, today we actually generate every 2 days. We create as much data as we did from the beginning of time, right, to 2003, every 2 days. So this is an increasing, on an exponential scale again, increasing amount. So DNA is one possible way of being able to store this information, because if you imagine data centers, how are they going to be able to store all this information? So one of the problems is, for example, the exponential growth of technology also has a curve of energy usage, and people are worried that you know, that this is a problem, that we'll get to a point whereby there is a you know, a plateau because we can't generate enough energy. But there are some other technologies which are coming in, such as fusion power, for example. But more importantly, there are more efficient ways in which we can store data. So data centers, even with solid-state devices, generate an awful lot of heat, and even though a lot of these data centers will have heat recovery in place, it is still incredibly inefficient a way of storing information. DNA actually can store information. In fact, 1 gram of DNA can potentially hold up to 455 exabytes of data. Now, what's an exabyte? Well, there's 1 billion gigabytes in 1 exabyte, okay? And there's 1,000 exabytes in a zettabyte. Now, by 2025, IDC, which is the International Data Corporation, predicts that there will be 163 zettabytes of data generated every single year. Okay, that's a tremendous amount of information, and it's not going to stop at 2025. It's going to continue to increase. So how do we store that? Well, given that you know, DNA, if we can store within DNA 455 exabytes of data within 1 gram of DNA, we could store the entire generation annually of human knowledge with just 350 grams of DNA. Now, I'm not suggesting that DNA is actually the answer to it all, because usable data and cold storage of data, is entirely different. So we need to be able to recall and recover the data in a usable format. And DNA probably is not going to be the best way to do that, but there are other technologies such as holographic technology, whereby we can store information, using crystals, and there's quantum storage as well, whereby we can potentially store incredible amounts of data, although in that way it could be incredibly dangerous and volatile. So it may be a case that we use a combination, something like a quantum storage device, to have very fast recovery and usable data, and something like DNA storage for large amounts of cold storage. So that's the where we are and how we're going to get to up to the point whereby there's mass amounts of information. How is this information going to be used? Well, we can't go through it all. I mean, we have search engines already where we have to rely on the search results, and it's impossible to go down. Most people don't go beyond the first page of a search result, but the pages can be, millions, if not tens of millions, if not hundreds of millions deep. There are websites where you can go to YouTube, for example, and that look for YouTubes that have 0 views. 95%, more than 95% of YouTube videos have no views and will never be viewed. It's a tremendous amount of information that needs to be stored. But this is one of the reasons why, and I've said before, necessity is the mother of all invention. Okay, so we need artificial intelligence to intelligently interrogate the data. We need ways in which we can use this data, and often, as I mentioned earlier, human intelligence being mostly down to the ability to extrapolate and in an abstract way connect patterns together. Well, if you've got access to massive amounts of data and you can intelligently interrogate that, who knows what kind of information we can actually draw, and from that collaborate, and from that create new things. So it's quite an important part of the move towards the technological singularity. So the next piece of technology is robotics. So obviously, in particular, I mean, robotics covers such a wide field. It's a massive field, okay? I mean, there are robots that we rely on within industry. There are robots which we rely on for mobility. Automation of vehicles, you could say, are robots. But specifically today we're going to talk about social robots, because this is ultimately one of the things that we want to try and get into people's minds and accepted in society, because there are a whole host of functions that robots aren't able to do today, which they're going to be able to do. So as you can see, this is Sophia the robot. Okay, so she was developed by Hanson Robotics, which is a company in Hong Kong. Dr. David Hanson is actually one of the founders of SingularityNET. So, I mean, she can, she has a bunch of cool technology. So she has speech recognition. She has the ability she's got depth scanning, so she can see you and understand expressions, so she can read your expressions and communicate with you in a very natural way. And she has a bunch of different AI programs that work within her to emerge a kind of illusion of a conscious. Of course, she's not really conscious, but it's the idea is that it allows people to interact in a more natural way with robots and AI. So I mean, the uses for this are endless. I mean, particularly I mean, the very standard idea of, a receptionist is a possibility. The reception of a business who used to sit in front of the door and welcome people is probably gone across the world now, which is a great shame, because reception is actually probably one of the most important jobs in a company, and should be employed by somebody who has ultimate knowledge about the business. Who better to have ultimate knowledge about the business than something that can be directly connected to the database of the business? Obviously, you don't want them to give away that database to just anybody, of course, so there is going to be some moderation. But in terms of social robots, I mean, this is going to be fantastic for the likes of healthcare, the likes of being able to offer forms of advice in a way in which people can actually understand and interact so it's less cold, and people will be able to relate more easily and understand technology that they're interacting with in a way which is more humanistic, without seeing all of the nuts and the bolts and the cold code behind it. Sophia, obviously famously, gained citizenship in Saudi Arabia, which caused quite a lot of controversy, but genuinely, Hanson Robotics has nothing but the best interest and really trying to help mankind, and bring social robots to the forefront. Once this is, we have artificial general intelligence. In terms of, I mentioned SingularityNET earlier, if we could plug in Sophia into SingularityNET, then she could gain the computational power of all different AIs. Now, I can talk to you a little bit about SingularityNET. SingularityNET is actually an organisation which is attempting to create an artificial general intelligence, but more than that, they are they will be creating a decentralized market for AI. So at the moment, AI is being developed by quite large corporations, so the likes of Google, Amazon, Facebook, what have you. And so they're creating AI because they've got a lot of money to throw at this. So, a lot of the smaller businesses don't have quite the funds. So it means that these companies have quite a large advantage over the rest of the market. Amazon, for example, recently created something called Amazon Go, which is a cash registerless and totally staffless shop, a supermarket. You can literally walk in, scan your phone, walk around, pick something off the shelf, put it in your pocket and walk out. And how that works is there's multiple cameras at the top, and they basically will follow you, identify who you are, identify what you've picked up and put it into your pocket, what you put in your pocket, and then will charge you once you've walked out. Now, large organisations can, drop a few billion or development into creating things like that. Smaller marketplaces can't do that, so they're not going to be able to compete. So SingularityNET, what they are doing is they're creating a protocol by which individual developers can place their artificial intelligent product, so their AI that they've developed, onto a marketplace, and anybody can then buy that, and anyone can take advantage of it. And it's, it is a decentralized marketplace, so there is no head. There is no, a corporate entity which is, pushing the direction towards financial gain. In fact, the governance of SingularityNET is held by the people that use it, and so it is a democratized way of doing it and opening AI to the world. So ultimately, the key benefit of SingularityNET is that they're able to take an AI can go onto the market. So if you think of an app store, if you developed an app and put it on the app store, it is isolated, people can buy it, yes you can market it, but ultimately its only use is if people download it. Well, with SingularityNET, what happens is if you can load your AI into the marketplace, that AI effectively can communicate with multiple different AIs, and multiple AIs can work together to create more emergent and wider services. So the example that I think is probably given the most is that if I wanted a document translated, and embedded within that document was a video, Google Translate, for example, may be able to translate the text, but it wouldn't understand the video. But if you place that, requested that service on something like SingularityNet, the service may be able to find an AI which can translate the text, an AI which can translate and understand the video, and an AI which could format all of that for you and give it to you in a single product. So it is a wider way of dealing with it. And if Sophia was connected to SingularityNet, her intelligence would be wider and she would be able to answer more generalistic questions and think in a more general way. We're hoping that the foundation and the democratization of AI will form the foundation of a positive singularity. So if you imagine an artificial general intelligence which ultimately is growing in power towards an artificial conscious awareness, you want to bring that. It's like a child, bringing a child up in an environment which is hostile. If in a hostile environment, wouldn't be a very pleasant person, we wouldn't have thought. However, if you bring up a child in a nurtured environment with freedom and the right principles and morals and standards built into the way in which they've been brought up, then it's likely to bring us into a positive singularity. So that's Sophia and robotics. Robotics obviously goes much further than that, as I mentioned before. It covers a whole range, and you could actually produce and do an event just purely on that aspect of it. But that's all I have on that. So in terms of spending for robotics, by the way, we're looking at by 2025, the global spending on robots will be about $66.9 billion. So that's quite a growth. As you can see on the chart, it also actually tracks as an exponential growth. Right now, I mean, we're in 2018, so the spend is circa 2000, so it's about 30 billion. But within the next 5-6 years, we're going to double that. So we're going to see a lot of robots all over the place. There will be robots that will deliver your pizza. There will be robots which deliver different items via drone. Drones themselves can be considered robots, and there will be self-flying drones. You'll get into a drone, it will fly you somewhere. They're robots. Robots will be omnipresent all the time, all around us. It's just a sort of part of the future and where we go. So now then. So talking about automation, and particularly we're talking about drones. One of the things that's leading us to the technological singularity is automation. So a lot of the tasks which have to be managed by humans today are managed because we can't program artificial intelligence to be able to deal with those tasks. And the reason is because of the fluid and dynamic nature that reality presents itself. So chaos theory and the very nature of how the world works means that an AI will have to think on its feet, will have to understand what's around it before we can automate. Okay, so at the moment we're getting there. We're getting there. It's by no means perfect. I mean, I'm sure that all of you have heard in the news we've had fatalities as a result. But I can tell you for sure that there are far less fatalities already today in terms of automated vehicles than those that occurred, through human error. And I think that I don't think it's ever going to be perfect. I don't think the moment you are kinetically moving somewhere, there is always going to be the chance of an accident. But we're going to get to the point where automation, particularly with vehicles, which will be the first implementation or first major implementation of automation, start to appear over the next 2 to 5 years, whereby you will see automated logistics, automated trucks on the road. So there is quite a bit of concern, in fact, that over the next 3 years, that a third of the workforce around the world will be lost. We'll have to retrain and do other jobs. In fact, this is something that I will be focusing on again at our next event, which is the social impact of technological change. So, but automation, I mean, the potential benefits, if you think about it, right today, I mean, vehicles, you have to learn how to drive. You have to be in perfect health. What about, people who have reduced mobility that can't get around from A to B? The aged and the young that perhaps shouldn't be driving an R. We're also in a situation whereby we don't know enough around us to be able to make proper decisions about how to act on the road. I mean, yes, we can all drive on the road from one place to another, and hopefully safely, but if something untoward does happen, how skilled and how good we are at reacting to that situation. And in fact, most pile-ups on the road that cause most deaths on the road are caused because of loss of concentration and human error. But with automation, and particularly within car automation, all of the cars will know what all the other cars are doing. So if we can get to a point whereby we've automated all of the transportation system, the chances of an accident happening are exponentially lower than they are today. So this is going to change the way in which we live and the freedom that we have as people. The cost at the moment is tremendous. You own a car, it costs you a tremendous amount of money to purchase the car, to run the car, the fuel and the impact on the environment of the fuel. All of these problems can be moderated and reduced to a minimum. Ultimately, technology that is increasing towards automation of vehicles has some major problems to overcome before we can implement it. Other than just the safety and the infrastructure to roll it out on the physical road, but also critically is the security of an automated system. If you've got a road filled with automated vehicles, the last thing you want is somebody to be able to hack into your car, which is happening quite frequently, and has been demonstrated that even on an Android phone, that you can hack into a car today, which isn't very good. So obviously we can't roll out at any scale automation unless we can solve that problem. But automation goes further than the car. Automation will take any area that humanity is currently conducted in that it requires a level of the ability to think on your feet, okay? With AI becoming stronger and the more ability to be able to deal with problems on the fly, jobs such as, could be accounting, it could be telemarketing, it could be, even management, mid-management, even some of the creative fields, will start to go. And once we'll get to a point where all areas of our supply chain are automated, there literally won't be any jobs. And that is also something we'll talk about at our next event, which is based upon what actually happens at that point, and technological advancements have led us to the point where we no longer need to work. But that's at the next event. So automation is another technology which is moving us towards the singularity. So how do we solve the problem in terms of how do we solve the problem of scaling, okay, with automation and security? Well, there's something called quantum cryptography, which uses a fundamental aspect of nature, part of the quantum mechanics, Heisenberg uncertainty principle, which basically says that you cannot know the momentum and position of a particle at any one time. So you can't know both things at any one time. So ultimately, using this kind of technology, we can create forms of communication, which means that if anybody was to intercept the information, that it would actually scramble the information. The information would scramble. The problem that we've got today is, back when I mentioned about big data and the amount of information that we're generating, is that if all that information has to be encrypted, the computational power to encrypt all that information, the overhead that places on that information would be tremendous. It would be so much that it would slow down the network and slow down processing and slow down the speed by which we can operate so much that it would just not work. It would collapse under its own weight. We would need more computational power just to manage the encryption than we have to actually do the job that we want to do. So we need some way of getting around this, and quantum cryptography is actually one of these ways, because it doesn't encrypt in the same way, because it relies on quantum mechanics. It means that rather than having complex algorithms to encode data, we just rely on the simple fact that if the data is sent and then interrupted, that the data is then scrambled. So it is no longer, so rather than it being encrypted to send it and then uncrypted the other end, it is sent, but then if it is instantaneously, if it is redirected or looked at by somebody who you don't want it to see, it scrambles instantly, so they cannot see it. So this is one way around it. And in fact, in China earlier in the year, there was a Chinese satellite which was able to quantum encode a two-way communication video link between China and Europe, and it was encrypted using quantum cryptography and was uncrackable. It was, I mean, I know we've heard the term uncrackable before, but I mean, this is genuinely uncrackable. It is not possible to crack, and it is absolutely imperative that we roll this out as a form of security on the likes of our technology, and particularly towards automation. It's also important, obviously, from a perspective of the Internet of Things and big data, because of the overhead, as I mentioned. So quantum cryptography is another one of the technologies which is critical to move us towards the technological singularity. Quantum computing, however, is a different paradigm and a different way of thinking about computation. So currently we have Moore's law, which means that the miniaturization of transistors has roughly doubled every 18 months, and the power of computing per $1,000 or £1,000 worth of computational cost, is increasing exponentially. So what we're looking at is at a time whereby the miniaturization of those transistors has got so down to the point that quantum effects start to take into place. So a quantum okay, how do I describe this to you? So a transistor ultimately is an on and off switch, so it allows electrons to flow through it or not. Okay. Now you miniaturize that down to the point where it's probably about 7 nanometers, and a quantum effect called quantum tunneling starts to occur, whereby the electrons can jump over the off barrier. So ultimately, you lose the ability to computate. There are some possible ways around this, but there is even if we were able to get around that problem, there's an absolute limit down to 1 nanometer, which is roughly about 2 electron, roughly two electrons wide, which ultimately, we can't go smaller than that. So does that mean that computation will actually slow down and stop? Well, if you actually look through history, we've got different paradigms. So the information technology has grown exponentially even before we had the microprocessor. So I mean, it started off, as I mentioned before, with the Neanderthals and the apes and the what have you. Moving forward to where we are today, and that's all been through different paradigms of technology. So whether that be passed on through drawing on caves, whether that be passed on through paper, whether that be passed on through vacuum tube, whether that be passed on through microprocessor, and so on. And so rather than Moore's law slow down, we will move to a different paradigm. Quantum computing is such a paradigm. It isn't a solution to all. Quantum computing is very good at some things, not so good at other things. So it's very good at crunching very large numbers. For one thing, it can, it has the ability to. It uses qubits. So quantum computers essentially, the growth isn't in binary. So binary is obviously ons and offs. Quantum computers can be ons and offs at the same time, and off and ons at the same time. So the amount of processing it can do is ginormous in comparison to computers. So, and that is compounded the more qubits that you add. So, and it's again, it's on an exponential curve. So, quantum computing is definitely going to be a technology which is important to get into the technological singularity, but it's certainly not the a silver bullet which gives an answer to all for the computational problem of Moore's law. So the next big thing, really, which is brings it all together, is decentralization. I'm sure you've heard of blockchain. Blockchain, particularly, obviously, was created when it's actually the concept of the decentralization and blockchain has been around for quite a while. Distributed networking and the ability to peer-to-peer networking has been around for quite a long time. What happened in 2008 was that a mysterious guy called Satoshi created something called Bitcoin. I'm sure you've all heard of it. Ultimately, it is a distributed ledger. So what is Bitcoin? Bitcoin is an encryption code which allows the addition of a block to the blockchain. And if you think of a blockchain as being very simply a spreadsheet, and that the information that is being added to the blockchain when a transaction occurs is literally just a row on the blockchain. So, but the great thing about it is it's decentralized. So there is no single server, or there's no single entity which controls that information. Once the information is on the blockchain, it is distributed to all of the different nodes on the blockchain. Now, decentralization as a technology, okay, is more than the technology itself. Okay, so it's a concept, and we're in at the moment, and we have been for for as long as business has been business. Centralized has been the way in which we have controlled power. And this is because of the idea of scarcity. So the idea that somebody has something and somebody hasn't something. So that you have the haves and you have the have-nots. You've got the areas with lots of things and the areas with not lots of things. And particularly for businesses, obviously, if you have a lot of things and you can sell it to people who don't have many things, you're in power of that. You're in control of that. you can control the power, the price, the distribution of it. It's totally in control of it, and that's because of scarcity. So, business ethics being what they are, I'm sure you've all heard the expression "all's fair in love and war." Well, business is war, and if you look at how businesses operate against each other, they are at war with each other in the way in which they operate. We have allies sometimes, but ultimately, they are in it purely for the profit. And the larger a business gets, the less important the individual customer gets to that business. And so, therefore, the rules that they have to enforce to maintain their profit become more and more, or less and less human in the way in which they are, because it is impossible, given the number of customers that perhaps they have, to actually deal with each issue and be flexible with each individual person. But ultimately, take food production, for example. Today, if you were to go in the developed world, go to a supermarket, pick up anything off the shelf, that is being produced by one of only 10 companies in the world. So all of the food that you consume is only produced by 10 companies in the world, and that's going to decrease. By 2025, it is estimated there will only be 4 companies in the world that control all of the food production of the world, and this is not good. This is not a good trend. Ultimately, we understand about monopolies and why that's not a great thing. So it's not the way in which we need to go. It's restrictive. So the concept of decentralization is that there is no corporate head. The people that are in control, it is true democracy. Is democratized in such a way that the information that's contained within is owned by everybody. It is there permanently. So decentralization doesn't just mean, from a software perspective, we're also going to need decentralization of hardware. So at the moment, you buy a computer, you're a company, you have the need to process X amount of data. You need to go and buy that data, processing capability in physical hardware, possibly cloud-based as well, some elements of cloud-based in there, but the majority of the power that you are generating to crunch that code will be physical hardware. So with the explosion of Internet of Things, and with technologies to increase the bandwidth of communication, so the likes of 5G, for example, we get to a point whereby we can connect together all of these bits of technology on the Internet of Things and share their computational power. So, we could actually create a decentralized hardware situation whereby computation is actually processed by all devices around the world, and so decentralization in itself is a fantastic thing, and we're seeing decentralization of versions of primary centralized services right now. With the likes of DTube for YouTube, for example, but we're seeing a whole host of different services which were currently charged and controlled by an entity, which are now entering the blockchain and entering decentralization, so that people can actually gain access to those services instead of being forced to pay for them by a corporate entity. So the other thing about that, of course, is that we're in control of what services are successful, and the democratization of services means we can choose which services are ethical against those which are not, which is another great thing. So it's putting power in the hands of the people, basically. So there's not just that though. There's a whole host of other merging technologies. We talked about the primary ones just now, but ultimately there are a multitude, and these by no means all of them. They're some of them. We've got bioengineering and life extension. So we're being able to understand what the process of aging, and being able to not just slow the process of aging, but in some cases we will be able to reverse the process of aging. We've got quantum cryptography, as we mentioned, quantum computers, drone transportation, brain-machine interface. I'm sure that Elon Musk would be interested in that. I know that he is. Fusion power obviously very, very, very important to us as a species, as our requirement goes up for energy. Smart cities, virtual reality, we're already here, but all of these different technologies which we could spend hours and hours and hours and hours delving into, but we just don't have the time today. But all of these are heading towards a point that technological singularity occurs. So we have a bit of a problem to overcome in the sense that our advance of technology is outstripping the changes which technology and the implications of technology actually is outstripping our social ability to cope. Our businesses aren't ready and are not able to cope, and political change is next to nowhere on the scale. So there are going to be some massive implications and some major issues that we need to face, and it isn't going to be, oh well, we're going to have time to deal with this. This is all going to happen over the next 5 to 10 years. So we're going to hit a point in the next 10 years whereby there is a massive amounts of disruption. I speak to people all the time on this subject, and it would surprise you, the majority of people, 90% of the people I talk to, have no concept of technological singularity at all. So they've got some awareness of the advance of technology, but they don't have an understanding of where that's going to lead. So actually this is something again that we will focus on. We will look at what the societal impact is of technological change. So to recap really, technological advance. We are in the knee of the curve of the exponential growth of technology. So we are about to go vertical in terms of the number of changes and the impactfulness of those changes of technology, okay? And what we need to do right at this moment is we need to take stock of exactly where we are, and make people aware, make as many people aware as possible what's coming, because we will reduce the overall impact, negative impacts that these disruptive technologies are going to have. Now it sounds like I'm saying that it's going to be a negative thing, and I don't think that it is. I'm a positive person. I think it's going to be a very positive thing. But I do think that we have to get over some upheaval, and we're going to have to change, and people tend to resist change. But unfortunately this change is not something that we have the ability to stop, I don't think, at this point. It is, as I mentioned last week, if you want to use the analogy of singularity for the technological singularity, we are already beyond the event horizon of the technological singularity, okay? There is very little we can do, in fact probably nothing we can do to stop the technological singularity from happening. All we can do is do our best to try and influence the positivity of that outcome, by investing in and in working towards technologies and projects which will move us towards a positive singularity, such as SingularityNET are. So, thank you again for coming. I know this one was a bit longer than the last one, and I mean I will be opening the floor to questions in a moment. So if you want to ask me a question and you want to put your hand up, probably now is a really good time to do that. Let me just wipe this clean just for a moment, and then so now if you want to put your hand up to ask some questions, you can. If you want to contact me, you're welcome to. I am obviously here. You can friend me here. My Altspace username is there. If you want to email me directly, you can. That's my email address there. And if you're a Telegram user, I am on Telegram, so you're welcome to direct message me. Now I have done this event without my headphones in, so what I'm about to do now is just put my headphones back in, and then we'll state some questions. So just bear with me. Okay, right, so, right, let me just close this down. Okay, so we have a question from Elefsky.
Yeah, you talk about the amount of data that is generated and how it should be saved, but how will we know if the purposes of which they are used are good? Who will just judge that?
Yeah, absolutely. It's a big question today. I mean, I think we all saw, Mark Zuckerberg be grilled in front of Congress, right? And respect to Mark. I mean, he was grilled for 5.5 hours. So, the truth is that information is already out there, and the idea of information ownership effectively is in the hands of anybody who can design tools to use it. Now, where we are at today is we're thinking that we should own our own knowledge and we should own our own information. But if you look at the reason why the situation exists, it's because people don't realize the value of their own information. But we're getting to a point now where the value of information is becoming exponentially insignificant in itself, and big data is becoming exponentially valuable, because it isn't your personal information can be used to identify that you might be interested in a product and to help try and sell that product to you. It could be very interesting to the government to find out which way you vote, so perhaps they could sway your vote, in that way. But the truth is that actually, if you look at the way in which people, have information flow between themselves and, say, the App Store, Google App Store, Amazon App Store, and Apple App Store, people are willing to give their information away for free. I mean, when they say, this app will have access to your call records and your texts and your, people are willing to click yes, that's fine, just because they want to play Flappy Bird. So it's literally information is already out there. The power, who's got the power, comes in terms of who has the algorithms and who has the tools to be able to analyze all of that information to pull out what they actually want. Okay, does that answer the question? Yeah.
Well, I'm wondering, but because I'm not sure if we will save the data into a blockchain, which is, in my perspective, the most secure thing for the moment to save things, because blockchain is very expensive.
Yes, yeah. Well, I mean, if you look at the likes of peer-to-peer networking in general, I mean, it is there's more information on the peer-to-peer network than there is probably in most data centers. If you look at the entirety of all of the data being shared on peer-to-peer, but yeah, I mean, information on the blockchain is permanently there. It is which in itself is a benefit, but it's also a negative. There is. Like for example, Google, who have had laws placed upon them for the right to be forgotten. I mean, if I'm a child and I make a fool of myself on YouTube, I should be having the right to pull that down, right? I mean, if I have committed a crime 20 years ago, and paid my dues. Maybe depending on what crime it is, of course, but people have the right to be in control of the data to that degree. If you place something on a blockchain, the information is there permanently. So I think there's a problem in that way. But the concept of personalized information, I think, honestly, your information is already out there. The cat has already bolted out of the bag. To try and now say, oh, well, actually, my information's valuable, I should take control of it, it's too late. The information's already out there. Maybe for children born now that we can have some rules to say that they're in control of their own data. But really, how long is that going to be before that really is valuable to anybody? Other than somebody selling nappies, we'll already be at technological singularity before that information is useful. So what I'm basically saying is, personalized information is already out there, and we can't take control of it anymore. As much as we want to, as much as people may want to, the information is already out there. It can be volatile though, and information can be lost, and often is. There's an internet, I'm sure you're aware of it already, called the Internet Archive, a website and a project which archives all the page impressions across the internet through time. So it's very useful for research, but we could do with something like that definitely on the blockchain. I agree with that, yeah. Does that answer your question?
Okay, thank you.
Okay.
Yes.
Good. Okay. Thank you very much. So we have another question from Jerry. We have a question from Jerry. Hello, Jerry. Do we have a question? No? No question from Jerry. Okay. Do we have Schürrle?
Yeah, right here.
Yeah. Oh, hello.
Hello.
Hi,
So,
how can I help?
So that last graph you showed, the one with the technological, there was a big rise in it, and political, social, and business was below
That
it.
one. Yeah. That
Yeah.
one.
Is there any plans to accelerate and merge them and be in the same level as technology change? And
Well,
if there is,
yeah.
what or how would they do it?
Okay, so this is an emerging situation, and there are no fast answers. It is one of the biggest problems that we're facing, and will be the cause of much upheaval across the whole world. I mean, socially, is probably the primary difficulty, really, in terms of, I mean, the main impact that we're going to see is through automation, and people will be in an existential problem financially. So, the current paradigm, financial paradigm, is, that we go out to work, right, and we earn the money, and we come home, we pay for our rent and our mortgage, we buy food from the supermarket, and we survive. It's relying on the job, relying on having a job. But as more and more jobs become automated, of course, that's going to have a massive impact on our society. What are people going to do? And there are some ideas behind that, such as universal basic income, which is the idea that we will be able to pay somebody entirely, just to be alive, just to kind of get us over this stopgap. But I do think that it's a short-term problem. This is a short-term problem, because once we get to the point whereby technology has automated all elements of a supply chain, so that's maintenance automated, that's energy generation automated, that's logistics automated, that's food production generated, that's mobility automated. All of these elements automated means that there's no need for money anymore. If all of those elements are automated, you don't owe money to anybody because it's just created. And I mean, there is a technology. There's a technology that I didn't have time to add in there, which is 3D printing and 4D printing. But 3D printing is going to be massive. I mean, the resolution that 3D printers operate today, is quite crude, to say the least. I think there's somebody got quite a loud thing going on here. Okay, so the resolution by which 3D printers operate are quite crude, but that's going to get better, and we're going to get to the point where there are HD 3D printers that can print at increasing resolution. So you will be able to take an inert material and print down to the molecular level. So we're talking technology which you'll be able to create very much like a replicator in Star Trek. It sounds far-fetched, but this is the conclusion of the advance of technology through 3D printing. So this solves many problems. We will be able to produce products without the need of supply chain at all. And what's more is recycling. We produce billions and billions and billions of tons of rubbish every year. Large swathes of the ocean are covered in country-size floating plastic rubbish tips. And there are solutions that people are coming up with microbes that eat it and turn it into different things. But the truth is, we want to get rid of waste altogether. And we can do that through 3D printing, because if something's broken, we can re-render it down to the molecules and reform it to whatever we want. And this is going to have. Sorry.
Wouldn't that be bad for business though?
Well, businesses will cease to exist entirely in the sense that they are businesses.
Okay.
The financial paradigm which we live currently. So so what's causing the social, business, and political change to lag behind the technological change is that the social, business, and political paradigms are all centered around a system scarcity, where there is things that have nothing, and there are things that people that have nothing and people that have a lot. And the money system, the financial system at the moment is based upon scarcity. But the technological singularity is creating a situation whereby scarcity we're in a post-scarcity reality, where abundance, where there is enough food for everybody, there is enough clothing and for everybody, and shelter for everybody, and the primary human requirements are dealt with. So at that point, the social change and the business change and the political change required, those problems disappear altogether, and we enter a totally different way of living. Now there's there's somebody who has quite a loud mic. I don't know who it is. I wonder if somebody could find that mic and turn that mic off. Okay, so I think we have a question now from Alina.
Hey there, first of all, I would really like to thank you for this amazing rush and all topics I would love to dive into because I can hear you have a lot of knowledge.
Thank you.
So I have two questions. So first of all, I think a big topic is monopolization, especially with Google and Facebook. Do you have any idea on how we can actually avoid this to happen? Because everything that we set up now is really important because I think the next 5-6 years. Hello? Are you there?
We cannot hear you.
What happened?
You hear me?
Yeah.
I disappeared. Crash.
Can you hear me?
Okay, don't panic. Don't panic.
Yeah,
You will come back in a few moments.
What happened? I think it's
crashed.
All right,
Yeah.
let's just give the presenter a few more minutes to continue their presentation. Just dealing with some technical difficulties currently, so please hang tight.
Yep.
Hello.
Good question, Alina.
Oh,
You said you have a good question.
I actually have a question too. If the robot's broken, if we had no businesses, over amount of time, people would forget how to do things, like build and that sort of thing.
The thing is,
when
though,
people. But what if one of the robots get broken? What if there's a glitch in the technology and we need a human to fix it?
Actually, I can really recommend your book that you should all read. It's from this year. It's called The Future of Humanity. And there are actually some of these topics that are pinpointing because in the future, when we have automated driving, literally we don't have any lorry drivers, right? Or bus drivers. So the author of this book is actually suggesting that maybe we should learn those people who are not driving lorries or buses, that we should actually get them to learn to code and actually when the robot or the car breaks down so they are able to fix the robot. So we're actually changing the way. So those are kind of points. But I can really recommend you to read that book. It's really interesting.
Hey, after this, who wants to go play Cards of Humanity after this? Cards Against Humanity.
well, I think that another important thing that is that if the robots drive cars and will happen less accidents, will we have enough organs to donate? But maybe the 3D print will bring us a solution.
Yeah, there are actually scientists working on printable organs. And
That is a thing. Just very basic things, though.
It
And
sounds
also
like
food-
this is some type
and
of
also
revolution or something.
food printers
Yeah.
are already.
It's called
They're
what's it
already.
called?
There's a French startup.
Third
They're actually
revolution.
built
Maybe there's a
3D
crisis
printer.
around the corner
Yeah, they're
Yep,
actually.
waiting
That's
for
true.
us.
Invest in
I
China,
think-
dude.
Technology is
from
taking-
USA.
But all this
It's great.
revolution stuff, it's quite far-fetched, and it it would probably not happen between 5 and 10 years. All the automation and stuff like that, it takes a lot more time.
2025.
Well,
Or
the
might-
X on the graph
we might
is
not
time,
know when
so
it's gonna
it's
happen.
not exactly. You know,
What if
it's not
somebody's
saying
accelerating it?
exists.
You know?
Not gonna happen. People are greedy.
Nice discussion is going on here.
It's I can see it in like say 30 years if it just continues like this, but I cannot see it being shared all over the world so far. But maybe something will happen.
See, like
I can
they were talking
imagine.
about, cryptocurrency.
Oh yeah,
Is there maybe, I don't know, maybe the dollar could be replaced by it at some point?
Nah.
I'm pretty sure the Federal Reserve won't go down by
I think that
You
in
still
some
have-
ways,
You still have the need for like gold, and you'll just make it currency another thing. You can't make it all virtual because, yeah, you still need something. All things have value. All material things have value, and you need stuff like different kinds of copper and stuff like that for making all this automation. There's a lot of needs and lots of materials, and that will just be a value, a new value, a new currency, or what do you call it? You can't make
You also
everything
have a
virtual.
paper wallet, like a cryptocurrency paper wallet, and give it to somebody so you have your own currency established, and give it to somebody and change it,
Well, just
trade with them.
just look at PayPal.
I think it's going to be I think it's going to be coexisting with all the other value stores that we have right now,
It's like
but in a more sufficient and friendly way.
just look at PayPal.
Alrighty,
Apple
folks.
Pay.
As a general announcement, our presenter might have had his internet crash, so what we're going to do is we're going to close out the event early, but feel free to continue having conversations. Oh, you're back. There you are.
I'm back.
Well, never mind. Let's
Well,
continue.
well, I'm sorry about
Just
that.
in the nick of time.
Yeah, my internet
did-
crashed. Thank
We
you.
didn't give up on you.
Yeah, so I was kind of worried that might happen. Yeah, so I'm thinking about changing my provider, eh?
Good idea.
So,
Welcome back.
right, thank you. So, where were we? Someone was asking me a question.
Yeah,
Aline.
that someone was me actually.
Hello.
Yeah, it was Alina.
Hi.
Hey, nice to meet you. First of all, I would really love to thank you for this awesome rush.
Thank you.
And I would actually personally would love to dive into each topic way more deeply, because from what I just heard the last almost 2 hours, you have a ton of knowledge. And first of all, I actually have 2 questions. So one question I have is, I think this kind of revolution we can't stop, because we in our company already have Pepper and all these robots, social robots around.
Yeah.
So one of my question is, how can we actually perceive monopolization from Google, Facebook, and so on? And do you have any ideas on how we can democratize it in a way? Because all the rules and all the things we set now are really important. Absolutely,
yeah. Well, you see, what actually the how do I answer this? So, I'm a community volunteer for SingularityNET. I'm not sure if you're aware of SingularityNET. Have you heard of SingularityNET before?
I heard it, but really abruptly, because through your talk you were pinching towards this direction, so I wanted to get your personally opinion from that.
Yeah, okay. Yeah, well, okay, so what's happening is that, as I mentioned earlier, the likes of, Google and Amazon, these companies have bottomless pits of money to invest in developing AI, and, so their vision is obviously to coin the market, and, this is a bad thing, because it means very much, that I mentioned earlier, with the companies that that they're in control of food. We need to be able to reduce the impact that one business can have on the whole world. Now, in terms of monetization, and particularly looking at the business ethic and the way in which these companies are looking at using this technology, they're obviously at an advantage. But what they're planning to do is they're planning to license this technology. So I mentioned earlier about Amazon and the Amazon Go supermarket. So they'll have this as a product, and what they'll do is all the other supermarkets out there, of course, I mean, they're struggling to make a profit. They're actually trying to deliver the service that the consumer wants, but and struggling to make a profit doing it. So how can they compete against something like Amazon Go? Well, what Amazon will do is they'll say, well, we will license our technology to you, and you become an Amazon store, and that's the way they'll go. And so that's what they're going to try and do. So what SingularityNET is ultimately a decentralized and democratized marketplace for AI services. So in that situation, the supermarkets, which are going to struggle and be forced into taking, a product and be effectively taken over, will be able to go onto the market and buy that service without having to have invested billions of dollars worth of, development to produce that. It is literally going to be able to be off-the-shelf automation. In the early days of SingularityNET, we're still in alpha now, and beta is coming very soon, and with full release we expect to be by the end of the year. So it's happening, and happening quite quickly. And the more smaller businesses are able to have the freedom to use the kind of technology that has only been the preserve of large businesses, the less power these large businesses have over the market. At the moment, they're the only people, like Google is the only company that offers an AI which translates as well as it does on all of the phones around the world in the way that it does. So it's cornered the market. So it has the ability, if it wanted to put an advert out within that, it's going to reach all those people. It's a monopoly. So if you have a marketplace where anybody can actually go and buy that service and it's as good as Google, then how does the power that Google has and the power that Amazon has, starts to ebb away, and they have less and less power to be able to use the power they've got to generate revenue. So I'm sorry, does that answer the first question?
Yeah, kind of. Because I think it's what we said now is really important, because it will have an effect on what's coming next.
Yes, yeah, very much so. Yeah, and I think that the problem is that things are changing so quickly. I don't personally believe we've got the time to be able to put in place the infrastructure to deal with all the change. I think that the change will happen, and we will have to deal with it. And I think that yes, what we say and what we do has an effect, but if you look at how the flow of technology has brought us to now, if I was to turn around and say that I wanted to set up a business as a taxi firm now, and I would find it really hard to compete in big cities because of Uber, right? And that'd be really hard, and it's not fair, right? Because that means they've cornered the market. So from my perspective, but if I could go to SingularityNET Marketplace and buy an off-the-shelf product which I can plug into my electric car and then gain the same advantage that Uber has, then I can compete in the market. And so that's how the change is going to come, and that's how it's going to be. So it's easy to understand how, how could anybody compete against Google or Amazon or Facebook, but they are big companies, they're massive companies, and they're going to get bigger, but likewise they're not as big as all of the other companies added together out there. And it's all of those other companies out there that are going to be able to start offering the same kinds of services that only Google and Amazon can. Okay?
Thank you very much.
Okay, do you have a second question?
Yeah, actually I have, if we have time. So
Yes, sure, by all means. Yep.
Last year I was in Stockholm, and there were some scientists talking that we literally have the technology ready for autonomous driving. But
Yes.
what we are facing, they could actually put them now onto the street. But what
Yeah.
we are actually facing now is the problem that our culture and society is not ready for it yet. So, and especially now, especially this year, with all the media driving the hypes of scaring people being out of jobs. Especially this year, I've seen so much rivalry going on, making people scared. That what do you think? I'm also facing this when we go to companies and show off Pepper and social robots, that there is some sort of anxiety and scared of the new.
Yes,
in order to be a bit more like a kid, and So do you have any ideas how we can kind of build a gap or a bridge?
Okay, so first of all, science fiction, apart from being an amazing thing to watch, is also very predictive. So the likes of Star Trek with the iPads and the mobile phones and holodecks and things like that. So we're not quite there with the holodeck yet. I mean, this is quite similar, but so this kind of technology has been portrayed in science fiction as being quite a negative thing. I mean, it's great cinema to have the Terminator, produce quite a negative view, but also, I mean, in the media, even outside of science fiction, in the media, you're quite right. There's a lot of negativity centered around, people lose their jobs and what's going to happen. And I think that there isn't enough people talking about the positive things that are going to happen as a result of implementing this kind of technology. So, but with automated vehicles, you're absolutely right. I mean, the technology is there. I mean, the technology is on board, by the way. It's actually the AI that drives cars is actually on board the car. But eventually that will be a case that the AI is disparate in the sense that different cars will connect to each other. But the infrastructure is the big problem. How do we do that? And I mentioned earlier that necessity is the mother of all invention, and I think that what's going to happen is that we'll have. I think automated vehicles will be through taxis and through logistics, so lorries and taxis first, okay? So what will drive that, and that's no pun intended, what will drive that is that the businesses will roll them out and find that they're more efficient in doing that, and because they're more efficient, they eat more of the market that they're in. And so their competitors are going to want to have the same capabilities that their other competitors have, and this will drive the uptake in the technology. So an AI taxi from Uber might be able to produce far more jobs in a far more efficient way than a human can, and so they're more successful than the competition. So, and I think that society is going to have to deal with the implications of that. So I don't believe that society is holding back the implementation of the technology anymore. I think that has been the case over the last 20, 30 years in the sense that, you know, there's planned obsolescence within product development, and that's mostly down to, you know, ensuring that the market's ready to buy your product. But I think that the change is now happening so quickly that the problem that we've got on the board behind me is that the society itself is going to have to learn to change with the technological advances, and that's going to be disruptive. I'm not going to lie about it. I think that will be disruptive, and you know, traditionally these kinds of problems have been solved by humans, but because of the advance of technology and the increased complexity by which our lives are, we're going to need AI to start to make these decisions and start to put infrastructure in place. And that's why AI is so important to be developed right now. I'm sorry, I hope that answers the question.
No, thank you very much. But what I can hear out as well, that you basically read The Future of Humanity, the book that came out this year.
Sorry, can you say that again?
Have you read the book The Future of Humanity this year?
No, I haven't.
You should read it. I can really recommend it.
Okay, could you perhaps send me a link to that?
Yeah, I can.
Yeah.
I will, definitely.
I'll put my contact details back there, so if you want to grab them, you can.
Yeah.
Okay, so we've got quite a few more questions, so let's take it from the top this time. So we've got Super Stig.
Yeah, here.
Hello.
I have a question. I think all these things with technology, I mean, that require a perfect world. But as the artificial intelligence increases, it also increases the potential for destroying the internet, because somebody get AI and they can produce extremely dangerous viruses that attack the computer much more efficient today. So this AI, that also eats itself.
Yeah.
So, and for example, or nature, big wars, if internet just go down, then totally nothing works. Then it's those people who have the old-fashioned business that will be rich.
Yeah. Well, heavens forbid the internet go down. I certainly wouldn't be able to be here if it did, and we experienced that once already today. So we certainly don't want to do that again. Okay, so let me answer this. But there are a number of extremely worrying technologies being devised today, and there are both negative and positive in potential. But this has been true of technology in general. You know, the advent of a weapon, you know, a bow and arrow could be used to find food, or it could be used to kill somebody. Okay, you know, and right the way through all throughout all of the technology. What the problem is, and you're quite right, is that obviously as technology increases, the dangers also increase with misuse as well. I mean, with biotechnology, for example, you know, we have right today the ability to create a super bug and kill everyone on the planet. We have that ability today, but we choose not to. You know, I mean, there's quite a lot of people that have a negativistic view of how the world is today. So this is driven by media, you know, and often you know, people's experience of day-to-day life is you know, quite negative in what they experience. But actually, if you look at the metrics, the world is continuously getting better. I mean, we always hear terrorism on the news, and terrorism's a terrible thing, you know, the loss of life is a terrible thing, and you know, but more people in 2017 were injured by a Q-tip than were injured through terrorism. So, there's a lot of negativity, there's a lot of negative information, but actually, if you look at it, it's not quite as bad, perhaps, as people tend to think it is. But I do take your point, and you're absolutely right. There are some disruptive technologies. I was looking at some technology the other day, in fact, whereby an AI can listen to your voice and can, after just only a few sentences, replicate your voice to the point where your own mother wouldn't be able to tell the difference, and it can say anything you want. There's coupled with another technology which allows you to take a video of somebody and you can make that person, you can connect that person and make them say anything at all. So, that's incredibly dangerous. You could have the President of the United States, declaring war, for example. So, you're absolutely right. There are possibilities of people that create nefarious AI which can, cause havoc on the world and on humanity. So, this is what we need to do. We need to ensure that we have an AI which is capable of detecting what is natural and what is artificial. So what comes from, what's real and what's not, basically. So if something is generated by AI, we need to be able to know that. So we need an AI curation of other AI. And we need a process by which, particularly with the AI virus, that obviously when we're talking about AI virus, we're talking about, we already have intelligent viruses. Viruses are really quite clever in what they do, and most of the algorithms are very simple as well. So that grows exponentially in power with an AI behind it. But what we need to do is we need to ensure that that the overall network by which AI communicates, whether it be blockchain, hash graph, whatever it ends up being, quantum internet, whatever it ends up being, that there is a specific AI curating the information, and that AI will be emergent. That's where we need to get to. But before we get to there, I agree, there's a danger. There is absolutely a danger. And internet security and technology is a constant war. It's a war between those that are trying to circumnavigate technology and those that are creating security to safeguard that technology. It's a constant thing. Quantum cryptography will only solve the problem of someone hacking in. It won't solve the problem, obviously, of an inside issue. So if you've got somebody who is absolutely outset and causing damage, then unfortunately damage will be caused. But I'm a big believer that we should look at history and understand that through history we have gone through transformative, disruptive technological changes many times before, and we haven't destroyed ourselves. I know that we're heading towards a time now where change is beyond our capacity to understand where it's going to lead us, but I'm erring on the side of positivity, and I think that although, yes, I acknowledge there's a danger, I think that we need to realise that on the whole, I don't think that we will be doing stuff like that. But that's I hope that answers your question. Sorry.
Yeah. It's definitely going to be an arms race between one AI will try to kill the other AI that try to kill the internet. So it will, still be the problems.
Yeah. Well, there's actually it's interesting you say that, because how we get to artificial superintelligence could be the fact that there is a merging of AGI. That maybe Amazon creates an AGI, maybe there's an AGI created by different states, and all these different AGIs work together in a global brain situation to create a singular AI. But if I'm honest, my personal view is that we will merge with technology. We already are. I mean, if you look at the way in which we use our mobile phones, and we hold the whole of human knowledge within our pockets. It's an incredible feat, of engineering and technology. But the only difference between that and what I'm talking about is we'll have that capability, but that will be held within us. We will have the ability to go onto the internet from our own minds, and have the ability to do all of the things that you can do currently within our bodies and within our own minds. And so, if I'm, let's say, my own personal view is that there will definitely be a group of people who are against that, and that these people will be coming from sources that you perhaps didn't even realize. So at the moment you might think that it would be the religious, but there are people who believe that humans should remain humans, and that the advance of technology and the ascension, if you like, of humans to become transhumans is something that we need to fight against. So there's a concept of, particularly from science fiction, that the machines will be against humanity, but actually I think it's going to be the other way around. I think that as we get more and more integrated with technology, I think there'll be a group of humans that are against technology. So it is a risk. I can definitely see the risk. Okay, so I guess we should have a couple more questions, and then really we need to call it a night. So let's have, I think I called out Cure before, but we never got a chance to speak to Cure, so perhaps we can have a conversation from Cure? No? No, I think Cure's not there. Okay, so then Tyler. Can we speak to Tyler? No, Tyler's not there either. Okay, so also gone. So in that case, then Catherine. No, Catherine. Catherine, no? No, not there either. Okay, Nick.
Nick is there. There is Nick.
Oh, hi, Nick. Hello. I can't hear you. Yeah, is your mic muted, Nick? Okay. Can't speak to Nick. Okay, what about Jerry? Oh, okay. It looks like that's it then, guys. Right, well, thank you again for coming, and I hopefully will see you again. We don't know when the next one's going to be, probably 2 weeks from now, and it will be focusing on the societal changes and implications. I know we kind of touched on that with Alina and with Superstig. This is probably the most difficult one to deliver, because there are both positive and negative elements to it, and hopefully we'll be able to push it towards the positive. But if you want to contact me, please do. You've got all the details there, and thank you very much.
Awesome. Thank you so much, Tim, and thank you also, Simon, for recording, and I hope everybody has an awesome day. Hopefully we'll see all of you guys later tonight. We have a few other events as well, so keep checking that events calendar.
Good event, Tim.